Okay, let's unpack this. $1 trillion.
Wow.
That's the projected size, roughly, of the global climate tech market by 2027.
It's a huge number. Really underscores the scale.
$1,000 billion, all focused on tackling climate change. Welcome to the deep dive. We try to cut through the noise for you.
Find what really matters.
Exactly. And today, our focus is sharp. Climate tech for rapid decarbonization.
And maybe we should clarify that term, rapid decarbonization. It's not just about slow, gradual change.
No.
It's about technologies specifically designed to really speed up cutting greenhouse gas emissions, like right now.
Making a difference fast, in the time frame we actually have.
That's the key, the urgency.
Right. And to help us get a handle on this, we've been looking closely at a new analysis. It's from Cognitive Market Research, published August 2024, called Accelerating the Future, How Climate Tech Drives Rapid Decarbonization. That's our guide today.
So the plan is?
The plan is to pull out the core insights for you. What are the key technologies? How are they actually being adopted? What are the real-world roadblocks?
The limitations?
Yeah, the limitations. And also why research, why digging deeper is so fundamental. We want you to finish listening feeling like you've got a good grasp. Informed, not overwhelmed.
Sounds good. So where does the report start? What are the sort of core components, the building blocks of this climate tech revolution?
Well, no big surprise, renewable energy technologies are right there at the top.
Makes sense.
We're talking solar panels, solar PV. The report really highlights how the cost has just, well, plummeted, makes it super competitive now.
Incredible change over a decade.
Totally. Then you've got wind turbines, obviously, and the report notes offshore wind is really opening up massive new potential there.
Yeah, bigger turbines, more consistent wind further out.
Exactly. Plus hydropower, which has been around forever, but still key. And geothermal, that seems to be getting more attention, where the geology is right, of course.
So those are the foundations for replacing fossil fuels in electricity generation.
Pretty much. But then there's the consistency issue, right? The sun doesn't always shine.
Well, wind doesn't always blow, which leads directly to energy storage solutions. The report stresses how vital these are.
Absolutely essential. If renewables are the engine, storage is the fuel tank you need to keep going.
Right. And the report dives into advanced batteries. Lithium-ion is dominant now, but it points to solid-state batteries as a big potential next step.
Higher density may be safer, too.
Potentially, yeah. That's the hope. And it also flags hydrogen storage systems, particularly for storing energy for longer periods, not just hours, but days or weeks.
Okay, so that helps balance the grid with all these intermittent renewables.
It's a huge piece of the puzzle. Finding cost-effective, efficient ways to, bank that clean energy, it's a major focus of innovation.
Got it. Okay, so generating clean energy, storing it. But the report also tackles the emissions we're still producing, doesn't it? That brings us to carbon capture, utilization, and storage. CCUS.
It does. And this one's maybe a bit more complicated or controversial sometimes.
How does the report frame it?
Well, fundamentally, it's about capturing CO2, mostly from big industrial sources, cement, steel, power plants, places where emissions are really concentrated.
And then what do you do with it?
Two main paths, according to the analysis. One is storage, basically pumping it deep underground into geological formations, locking it away.
Permanently, ideally.
That's the goal.
Yeah.
The other path, getting more buzz, is utilization, using that captured CO2 as a resource.
Well, like, what can you make?
The report mentions things like building materials, some types of chemicals, maybe even fuels down the line, turning waste into something valuable.
Interesting. What's the report's overall take on CCUS? Bullish? Skeptical?
I'd say cautiously optimistic. It acknowledges the potential, especially for hard-to-abate industrial sectors, but it also flags the challenges.
Like cost.
Cost, definitely, and the sheer scale of infrastructure needed for transport and storage. It's not a simple fix and needs more R&D to bring costs down.
Right. Okay, so cleaning up sources. What about the energy we use every day in our cars, our homes? The report talks about electrification technologies.
Yes, shifting away from burning fossil fuels directly in those applications.
So electric vehicles are the obvious one.
Absolutely. The report tracks the rapid growth there, not just personal cars, but buses, trucks, commercial fleets too.
And for buildings?
Heat pumps are the big focus, replacing gas boilers or oil furnaces with electric heat pumps for heating and cooling.
Which are much more efficient, usually.
Much more efficient. But, and the report stresses this, the real climate benefit depends on the electricity itself being clean.
Ah, so it all loops back to decarbonizing the grid with those renewables and storage we talked about.
Exactly. Electrification only gets you so far if the power plant supplying the electricity is still burning coal or gas. It's all interconnected.
Makes sense. Now, it's not always about the big headline-grabbing tech. The report also highlights energy efficiency innovations, right?
It does, and this is crucial. Sometimes the energy you don't use is the cheapest and cleanest.
Like what sort of things?
Well, improvements in industrial processes, making manufacturing less energy intensive, smart systems in buildings optimizing lighting, heating, cooling automatically,
Even just better insulation.
better insulation, more efficient appliances in our homes, fridges, washing machines, TVs, all these incremental gains add up significantly.
So it's about reducing the total demand for energy in the first place.
Precisely, doing more or the same with less energy input. It's a fundamental part of the rapid decarbonization picture.
Okay. And the report casts the net even wider, looking at sustainable agriculture practices and circular economy principles. How do they fit in?
Well, agriculture is a major source of emissions, methane from livestock, nitrous oxide from fertilizers. So the report points to practices like no-till farming, better manure management, things that reduce those emissions.
And can some practices even store carbon in the soil?
Yes, exactly. Regenerative agriculture aims to do that. So it's both reducing emissions and creating a carbon sink.
And the circular economy part.
That's about moving away from our take, make, dispose model, designing products for durability, reuse, repair, and recycling.
So less raw material extraction, less manufacturing energy, less waste?
Exactly. It reduces the emissions embedded in all the stuff we consume. It's about system-level change, rethinking resource flows.
Okay, so that's a really broad toolkit of technologies and approaches. Impressive. But the report must also talk about how we actually get these things deployed at scale, quickly.
Oh, absolutely. The report is very clear. Having the tech isn't enough. You need to weave it into the global economy. And it argues for a multifaceted approach,
Meaning?
meaning it takes a combination of things working together. The report breaks it down into three main pillars: strong policy frameworks, sustained investment and innovation, and the right infrastructure and market incentives.
Okay, let's dig into those. Robust policy frameworks. What does that look like in practice, according to the analysis?
Several key tools get mentioned. Things like setting strict emission standards for industries, for vehicles. That forces change.
The stick, basically.
Kind of, yeah. Then there are the carrots, tax rebates, subsidies, making solar panels or EVs cheaper for people and businesses to buy.
Accelerating adoption.
Exactly. And then, crucially, carbon pricing.
Ah, putting a price on pollution. How does the report see that working?
It discusses both main approaches: cap and trade systems, where there's a limit on total emissions and companies can buy and sell permits to emit.
Creating a market.
Right. And also carbon levies or taxes, which just put a direct cost on each ton of CO2 emitted. The point is, these mechanisms make polluting more expensive and clean alternatives more attractive economically.
Got it. So policy sets the rules of the game. What about the second pillar, investment and innovation, fueling the R&D engine?
Yeah, this is critical for developing the next generation of climate tech and bringing down costs for existing ones. The report highlights the need for both public and private money.
Government funding for basic science.
Yes, foundational research, but also venture capital, private equity funding for startups, for scaling up technologies that show promise.
Bridging that gap between a lab idea and something you can actually buy and install.
Exactly that. The report stresses the need for better mechanisms to support that whole innovation pipeline, from discovery to market readiness.
Okay, so we have policies creating demand, investment creating supply, but the tech needs to physically connect, right? That must be the infrastructure development and market incentives part.
Precisely. You can have millions of EVs, but they're useless without chargers.
Good claim.
You can have huge wind farms, but you need upgraded grids to handle that power flow. So the report talks about massive investment needed in charging networks, grid modernization, pipelines for hydrogen or captured CO2 potentially.
Your physical backbone.
The physical backbone. And alongside that, market incentives. Things like government buying programs committing to purchase green steel or sustainable aviation fuel, for example.
Creating guaranteed demand.
Exactly. Or regulations that make it easier to integrate these new techs into existing supply chains and systems. The report specifically calls out energy storage and grid upgrades as urgent infrastructure needs.
It really sounds like a massive coordinated effort is needed. Policy, money, infrastructure, all moving together.
That's the message. No single piece works in isolation.
Okay. Now, the report is realistic, right? It doesn't just paint a rosy picture. It must address the hurdles, the limitations of climate tech.
Oh, definitely. It dedicates significant space to the challenges. One of the biggest is simply the high cost of many of these
It's
technologies.
still too expensive.
For some applications, yes,
Hmm.
especially for developing countries or smaller businesses that maybe don't have access to cheap capital. While costs for things like solar have fallen dramatically, deploying cutting-edge solutions or retrofitting entire industries still requires huge upfront investment.
That makes sense. What about scalability? Can we actually build this stuff fast enough and big enough?
That's another major challenge the report flags. It uses carbon capture and storage, CCS, as a prime example.
Why CCS specifically?
Well, the technology itself is complex. Building the capture facilities, the pipelines to transport CO2, finding and verifying suitable underground storage sites, it's a massive undertaking. The report suggests that while it might be vital for certain sectors, scaling it up globally to capture billions of tons of CO2 is a very significant hurdle, both technically and economically.
So, potential, but hard to scale quickly.
That seems to be the assessment.
And we already touched on the intermittent nature of renewables. Sun and wind aren't constant.
Right. And the report comes back to this as a limitation that needs constant attention. It highlights our dependence on energy storage to smooth out those fluctuations.
And storage itself has limitations.
Cost is still a factor, though improving. And we need more options for long-duration storage beyond just a few hours. So further breakthroughs and cost reductions in storage are seen as essential to fully unlock the potential of renewables.
Okay. Any other big limitations mentioned?
Yes, technical and regulatory obstacles.
Hmm.
On the technical side, just the complexity of integrating brand new technologies into systems that have existed for decades, connecting offshore wind farms deep out at sea to the onshore grid, for example. It requires new engineering solutions, new standards.
Regulatory.
The report points to the uneven landscape globally. Different countries have different rules, different levels of policy support, different permitting processes. This fragmentation can slow things down, create uncertainty for investors, and make it harder to deploy solutions across borders.
So a patchwork of rules doesn't help rapid global deployment.
Not really. Harmonization and consistent long-term policy signals are important.
Okay, so despite these challenges, cost, scale, intermittency, integration, the report is still fundamentally positive about the value of climate tech, isn't it? And the value of research.
Absolutely. It frames climate tech as offering the most concrete, innovative solutions we have to actually tackle the climate crisis.
What are the core benefits it highlights?
Well, the primary one is obvious. Reducing greenhouse gas emissions to limit global warming, but also transitioning to a low-carbon economy, reducing our dependence on volatile fossil fuels, which has energy security benefits too.
Right.
Improving energy efficiency saves money. And importantly, the report emphasizes the economic opportunity. Building these new industries creates jobs, drives innovation, boosts growth. It's not just about avoiding disaster. It's about building a better, cleaner economy.
And achieving climate goals, like those in the Paris Agreement.
Indispensable for that, yes.
Now, how does primary research fit into this? Getting out there, doing original experiments, surveys, collecting new data. Why is that so valuable, according to the report?
It's vital for several reasons. First, to actually test and validate these technologies in the real world. Do they perform as expected? What are the unforeseen issues?
Ground truthing the models?
Exactly. Yeah. Primary research helps understand the actual effectiveness, the costs, the operational challenges. It also helps understand market needs and user acceptance. What do people actually want or need from an EV charging network, for instance?
So it informs better design and deployment.
Yes, and enables evidence-based decision-making. Policymakers need reliable data from primary research to know which technologies to support, how to design effective regulations. It helps tailor solutions to specific regions or industries.
Guiding investment and policy effectively.
Couldn't do it without that groundwork.
Okay, now the report also connects climate tech development to secondary market research. Could you unpack that link for us? How do they relate?
Sure. So primary research is about generating new data. Secondary research is about analyzing existing data. Think market reports, industry analyses, competitor assessments, databases of patents or investments.
Looking at the bigger picture using data that's already out there.
Exactly. And the report argues this is incredibly valuable for the climate tech sector. It provides critical insights into the overall landscape.
Like what kinds of insights?
Well, you can see which technologies are gaining momentum, where the venture capital money is flowing, which companies are emerging as leaders, what regulatory changes in different countries might create new opportunities or risks.
So secondary research helps you understand the context in which climate tech operates, the trends, the competition.
Precisely. It helps stakeholders, innovators, investors, policymakers identify current gaps in the market. Where's technology needed but not yet available? It helps spot emerging trends. What's the next big thing in battery chemistry? It points towards prospective opportunities. Which regions are poised for rapid EV adoption based on policy and consumer interest?
It's like having market intelligence to guide the tech development.
That's a great way to put it. The report concludes that integrating the insights from secondary research with the actual development of climate tech makes the whole process much more effective.
You can target your R&D better, refine your business strategy, anticipate market shifts.
Exactly. It leads to, as the report says, improving the efficacy of strategies and ultimately helps speed up those rapid decarbonization efforts we need, using market knowledge to accelerate technological progress.
Okay, that makes a lot of sense. So let's try to pull this all together as we wrap up our deep dive. Based on the Cognitive Market Research Report, what are the really crucial takeaways about climate tech for rapid decarbonization?
I think first, it's that climate tech isn't one single thing. It's this diverse suite of solutions. Renewables, storage, CCUS, electrification, efficiency, even how we manage land and materials, all advancing quickly.
Right, a whole toolbox.
Whole toolbox. Second, getting these tools used effectively requires more than just invention. It needs that supportive ecosystem.
Yeah.
Smart policy, consistent investment, and the right infrastructure, all working in sync.
The coordination piece is key.
Definitely. Third, we have to be realistic about the limitations. Cost, scalability, the intermittency of some sources, integrating them into legacy systems. These are real challenges we need to keep working on.
No magic bullets.
No magic bullets. But fourth, despite those challenges, the potential value is immense, not just environmentally, but economically too. And finally, the report really highlights the synergy between hands-on primary research testing and validating and strategic secondary research understanding the market landscape. Both are crucial for speeding things up.
That's a great summary. And for you listening, we really hope this breakdown gives you a clearer picture of this incredibly important field. As we said, climate tech isn't some far-off niche area anymore.
No, it's fundamental. It's shaping industries, investments, geopolitics, our future, really.
Absolutely. Which brings us to a final thought, maybe something to ponder after listening.
Okay.
Considering the huge scale of the challenge, the trillions potentially being invested, and just how fast things are moving in some areas, what truly unexpected, maybe even disruptive breakthroughs in climate tech might realistically emerge by, say, 2030?
That's a fascinating question. Things we aren't even focusing on heavily right now.
Yeah. And how might those potential surprises fundamentally change our current strategies or timelines for decarbonization?
It's a dynamic field, that's for sure. Predicting the future is tough, but thinking about those potential game changers is definitely worthwhile. The next few years are going to be critical.